Hi, you guys, it's Mrs. Leuse. I am showing you a few examples as far as how to complete your performance task packet. So it looks like this. This is your answer sheet, and then inside you'll see all these task cards. It looks like a lot, but they're just really big, and it's really just a review of of prime factorization. So what I'm going to do is I'm going to go through and do some examples. I'm going to do the 4 that are on the back. So notice that the numbers are written on each problem. So this one is number 5. So after I solve it, I will write my answer in box for number 5, which would be right here, and so on. So I will solve these ones for you so you have some good examples and reminders of how we work with prime factorization, and then you guys will be good to go. All right, so let's look at number 5. It says, what are the prime factors of 54? Okay, so if they ask you for prime factors, I want to know numbers that multiply together and give me a 54. So you're going to want to write down your 54, and you can start making a factor tree. You can also just list out all the numbers. So I know 1 and 54 are my first 2 factors because 1 times 54 is 54. And then I'm going to go up from 1 all the way until I go through every possible multiplication fact or prime factor that multiplies together and gives me a 54. So again, there's 2 ways you can do it, but you want to make sure you get all of the factors that would multiply and give me a 54. So there's a couple ways we can do this. It relates to multiplication, of course, and even division, and I'm going to show you how to do that. Hang on one second. Let me pause this. Okay, so I'm going to go to the next number in my number line, which would be a 2. Is 54 divisible by 2? If it is, 2 and another number would multiply together and give me a 54. So I might need to come over here and divide and find out. So let's see, 54 divided by 2. 2 goes into 5 2 times because 2 times 2 is 4. Then I subtract, 5 minus 4 is 1, and bring down the 4. 2 goes into 14 7 times because 7 times 2 is 14. So I know that 2 and 27 are factors. 2, and I'll put this one up here, 27. How about the number 3? Is 54 divisible by 3? So I would go 54 divided by 3 and find out. 3 goes into 5 1 time, because 1 times 3 is 3. 5 minus 3 is 2. Bring down the 4. 3 goes into 24 8 times, and 8 times 3 is 24. So look at that, 3 and 18. Notice how I started big, 1 and 54, and now I'm filling in the blank spots. I'm finding all the factors by moving down the number line. This, honestly, I think is the easiest way. So we got 1, 2, 3, 18, 27, 54. Let's see if 54 is divisible by 4. And I actually know it's not. I know it's not divisible by 5. What about 6? Yes, 9 times 6 is 54. So that would be 6 and 9. 10 does not go into 54, neither does 11 or 12. Let's see, 54 and 13, 54 and 14. 54 and 16, 54 and 17, and then I get to 18, and I already did 18. So once I've gone through, if you start with 1 and it's in the number itself and then work all the way up, this is the easy way to catch all of the factors. All right? Okay, so what I'm going to do now is list these for my answer on number 5. So let's just take off the answer sheet here. So number 5 is up here, and the answer was all the factors, which were 1, 2, 3, 6, 9, 18, 27, 54. Keep in mind, you guys can use a multiplication chart if you want to help you out. That's fine. But I do want to see your work. So let's go ahead, and now I'm going to do an example for number 6. It says 2 times 3 times 5 is the prime factorization of what number? So remember when we do a factor tree, it branches out and shows us a prime factorization answer that would look like this. So now we're working backwards. So I'm going to go ahead and multiply these numbers together to figure out what this came from. Well, 2 times 3 is 6, and 6 times 5 is 30. So this prime factorization had to have come from the number 30. Let's double check and go back and write the factor tree, and we should come out with 2 times 3 times 5. Well, 30 factors out into a multiplication problem. There's a few options, but I'm going to go ahead and do 2 times 15. 2 is prime, so that's done, but 15 can factor out into 3 times 5. And then both of those are prime, so I'm done. So there you have it. 2 times 3 times 5 is the prime factorization for 30. So in my number 6 box, I'm going to write the answer is 30. All right, let's go ahead and do another example, number 8. It says, Chris found that the prime factorization of 20 is 2 squared times 5. Is he correct? Why or why not? And explain. So what you'll want to do is see if he's correct. So let's go ahead and factor out 20 and see if we end up with 2 squared times 5. Remember that 2 squared times 5 means that our prime factorization was 2 times 2 times 5. They just rewrote 2 times 2 with an exponent. 2 times 2 is the same thing as 2 to the second power. So let's see if we factor out 20 and get a 2 times 2 times 5 as our prime factorization. Well, 20 factors out to 5 times 4, and 4 factors out to 2 times 2. So yes, I would have 2 times 2 times 5 as my prime factorization. And again, I can rewrite that as 2 squared times 5. So the question was, is Chris correct? So in my box number 8, I'm going to write yes, he is correct. And then explain why. I'm going to write down that 2 and 5 are factors. Oh wait, I'm sorry, 5 and 4. 4 and 5 are factors of 20. And because I found that 5 times 4 are factors of 20, the prime factorization came out to 5 times 2 times 2. And there you have it. All right, you guys, so I want you to go through and practice these. Make sure you write your answers on your answer sheet and bring all of this back to school so I can see how your practice went. All right, you guys, I will talk to you later.